Hey guys, so this is the next set of notes, the 1.2, about comparing linear functions and inputs and outputs. So we have what is known as a parent function. So a linear parent function is just the function that it starts out as, and then we're going to look at other line functions or linear functions and compare them to the parent. So the parent function in all of this is y equals x is known as the parent function for all of these. Now, y equals x has a domain of all reals because it doesn't matter how many different types of numbers you put in for x, it doesn't matter what numbers you put in, you are going to get the same result for y. So therefore the domain and range for the parent function y equals x are all reals because there are an infinite amount of numbers that you could put in. So when you're going to graph the parent function, we have 0, 0, 1, 1, 2, 2. So this is what the parent function y equals x looks like when you go to graph it. The table of those numbers are, if we use the numbers 0, -1, 0, 1, 2, 3, 4, then if I plug in -1 into the equation, my answer for y is -1. My answer for 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. So what patterns do you observe in the table and graph of the linear parent function? Well, all the x's and y's are the same. So in that function, y equals x, all the x's and y's are the same, okay, when you're going to plot them. So for these next couple examples, it says for each linear function below, compare it to the linear parent function, which is the y equals x, in terms of vertical shifts and steepness. Identify the part of the equation in y equals mx plus b that determines the change. So first we got to figure out what the change is in steepness or whether it moved, a vertical shift. So in your first example, we have that the line labeled A in red. If you look at that in terms of steepness and compared to the black line, which is the parent function y equals x, we notice that line A is steeper. It's steeper than that. It's a steeper slope. Okay, it goes more straight up and down, which makes it a steeper slope. We also notice that if you look at line B compared to the black is less steep. Okay, so line B is less steep. Do they move positions? No, one is not higher or lower than the other. They're at the same spot. They're still at the 0, 0, but one is steeper and one is less steep than the other. So if we're looking at the steeper slope A, we have to write the equation of that line. When you're writing equations of a line, remember or recall that you have to find the slope of the line because you've got to make it y equals mx plus b. So you have to find how many, remember slope is rise over run. So you have to find how many it went up and how many it went across. So if I start at the center here, then I'm going to count how many I go up until I hit and across until I hit the next dot that is on my line A. So I'm going to go up 1, 2, 3 spots and right 1 spot. So 3 over 1 becomes my slope, which is just 3. So when I write my equation, y equals 3x, and then we would typically put the plus b, but the b is at 0 here. So I don't need to put the plus 0. So the equation of that line is y equals 3x. Okay? When I'm trying to write the equation of the green line, what I'm going to do is, again, start at the middle here, this middle point here. I'm going to count how many I went up and to the right till I get to this next point. So this one, I went up 1 and right 3. So since I went up 1 and right 3, that would be a fraction slope of 1/3. So I'd write my equation y equals 1/3 x. And again, it started at 0, so I don't need to put it. So in this first one, we have that the difference between the two equations is they have different slopes. And since that tells us whether it's steeper or less steep, that tells us that the slope tells us how steep a line is. Notice that the 3 is further from 0 than 1/3. 1/3 as a fraction or as a decimal is closer to 0. So what we can conclude from that is that the closer the slope is to 0, the less steep it is. And the further the slope is to zero, slope is from zero, the steeper the line. So the further the slope is from zero, the steeper the line. And that's what we can conclude from that. In the next example, let's look at what we have for lines A and B. So in line A, in relation to the black function, again, all that we did, notice that it has the same slope, so they're equally steep. I'm going to call that equally steep to the parent function, but it's at a higher point. And then the B line is, again, equally steep. It's still facing the same direction and going at the same slope and has the same slope, but it is at a lower point. So let's see what this looks like when we write our equations. So when we write the equation for A, remember, we're going to pick a point on the line, the y-intercept of that point, and then we're going to pick another point and we're going to count the slope for it. So if I start here at this 6, I'm going to go up 2 and right 2. So my slopes becomes 2 over 2, which is just 1. So when we write our equation, we say y equals 1x plus my b this time is the point on the y-axis, which is 6. So the first equation is y equals 1x plus 6. Okay? The green line, or the line B, again, we're going to find the slope. So I'm going to pick this point here, that's the y-intercept, and then this other point that falls on the line, and I'm going to count 2, up 2, over 2. So 2 over 2 is again 1. So again, it has the same slope. So we have y equals x, but our y-intercept this time is -6. So we write that as -6. So if you notice the difference between these two equations, the difference here is the y-intercept. This one is +6 for line A. Line A has a y-intercept of 6, and line B has a y-intercept of -6. And notice that that refers to whether it is at a higher point or a lower point. One more example here. If you look at the equation of A, or if you look at the line A and compared to y equals x, notice that it is going the opposite direction. So it's the same steepness, but it's in the opposite direction, okay? So when we write that equation, if you were to write this equation of the line for A, it starts at 0 and it goes up 1, 2, and left 2. So up 2 is positive, left 2 is negative, and 2 divided by 2 is -1. So remember the parent function y equals x has a slope of 1. And now this function a is going to have a slope of -1. So our equation here would be y equals -1x. So it goes in the opposite direction. So you know that by looking at the equation, y equals x is +1, and then to go the opposite direction, you're going to say y equals -1x. Okay? So conclusions from these set of notes are that y equals mx plus b, when you have the equation of the line, y equals mx plus b, m is the slope, and the slope in particular, let's color it blue. The slope in particular tells you how steep a line is, the steepness of a line. Okay, so it depends on if it's closer to zero or farther from 0, and that tells you whether it is steeper or less steep. And the y-intercept of your equation, y equals mx plus b, tells you whether it is at a higher or a lower point. So knowing all this information, this is the topic that you're going to get in ALEKS that you're going to have to figure out based on no pictures of graphs, but based on the equations of the lines. So it says, compared to the graph of y equals x, the graph of y equals -2x is steeper, equally steep, or less steep. So if you look at since steepness refers to slope, since you have to look at slope in order to determine the steepness of a line, the slope of y equals x, remember, is just 1. the slope of y equals x is just 1, okay? And then the slope of y equals negative 2x is negative 2. So the slope changed. The question is, did the slope get further from 0 or closer to 0? In fact, it got further from 0, right? It started at 1 and then it went to negative 2, so it got further from 0. So if we look back in our notes, when something's further from 0, it becomes a steeper line. So our answer here would be that the line is steeper, part A. The next question says, compared to the graph y equals x, the graph of y equals negative 2x intersects the y-axis at a higher point, the same point, or a lower point. Well, remember, when we're talking about a higher or a lower point, we're looking at the y-intercept in our equation. And if you look at that closely, the y-intercept in the first equation is nothing, is 0. So we've got plus 0. And the y-intercept in the second equation is nothing. So you've got another 0. So they're the same exact number, so therefore they intersect the y-axis at the same point. So slope tells you steepness, and y-intercept tells you whether it is at a higher or lower point. So look at our next example. You have y equals x and the graph y equals x plus 4. So notice that there is no change in the slope. The slope of this first one is 1. The slope of this next one is 1. So there is no change in the slope. The slopes are the same. Since the slopes are the same, then they must be equally steep. The next question, the second question, always asks you about the y-intercept. Notice here that there is a change in the y-intercept. This y-intercept is 0, and this y-intercept is 4. So did it intersect the y-axis at a higher point or a lower point? Well, 4 is greater than 0, so we know that it intersected the y-axis at a higher point. Okay, this one takes a little bit of practice, so take your time with these and look back on your notes to try to figure these ones out. And then the last topic that you guys have for this time is inputs and outputs of linear functions. So this is pretty straightforward. It's going to give you an equation. It's going to give you an equation or a linear function. C of p is equal to 30 times p, and then it's going to give you some sort of value to input. So it says, what is the cost of the admission for a group of 5 people? Well, the 5 is going to be input in for the p in your equation because it represents people. So if you do that out, you're going to find that C of 5 people, the cost for 5 people is 30 times 5, which is equal to $150. And that's your answer. So you just input the number that they give you. So let's look at the next example. In our equation, we have that W, or A of W, which stands for the amount of money in dollars that she needs after a certain number of weeks. So A of W is equal to 700 minus 18W, okay? So in the first question, it says, how much money does Diane still need after 5 weeks? Well, 5 here is going to be plugged in for the W, so we're going to do the same thing we just did in the previous one. So A of 5 is equal to 700 minus 18 times 5. And if you do that on the calculator, you have 18 times 5 is 90. So you have 700 minus 90 is 610. So that's how much money she needs after 5 weeks. And the next example, or the next question asks, if Diane still needs 394, how many weeks has she been saving? So notice that they switched it around now, and now what they gave you is the amount of money that she still needs. So the A in our equation, and then we have to find the W, or the weeks in our equation. So what we're going to do here when we set it up is we're going to say 394 is equal to 700 minus 18W, and we're going to solve for W. So think back to solving equations. What I'm going to do is I'm going to make the variable positive, so I'm going to add 18W onto both sides. And then I have 18W plus 394 is equal to 700. Okay, and if I keep going here, I'm going to subtract the 394 from the 700. So 700 minus 394 is 306. So I have 18W is equal to 306, and then I'm just going to divide by the 18 to get my W, or the amount of weeks. So divide that by 18 and you'll get 17 weeks for your answer there. All right, that's the end of the second lesson, the lesson 1.2, and try to practice on Alex and let me know if you have any questions. Good luck.